know, Welcome. Yeah. Okay, yeah, I guess we can get started. Uh, Welcome everybody to this webinar on, I think, a very important topic that I think everybody is really, really curious to know more about, which is CBSE's new AI and CT curriculum. For those of you who may not be aware of this, is that, okay, CBSE has launched a new AI and CT curriculum, basically restructuring their class 3 to class 8 format and how they want to actually tackle computational thinking and AI in their education. And that's exactly what we want to talk about. And we're not going to be just saying exactly what is in the curriculum. We'll also be answering some of the questions that I'm sure all the educators here will have about how do we actually take this forward. Let me introduce the panelists here who are actually going to take you through this. We have Ashwini Chandrasekhar and Bharat Arunchalam, who are actually part of the AI and digital thinking team here at Education Initiatives. They've been working over the last 2.5 years on developing various ways to test and also improve computational thinking, AI skills, and digital literacy. And I'll actually hand it over to them so that they can actually take you through what CBSE has in store for you.
Thank you. Thanks, Siddharth, for the introduction. It's great to see 500 plus participants, and it kind of underlines the importance of this particular document that CBSE has released at the start of this month. Ashmi, will you be presenting your screen?
Yes. Yes.
Yeah.
Is it visible, please?
Not yet.
Just a second.
Yeah.
Is my screen visible?
Yes. Yeah, it is visible right now. Yes. Yeah. So, yes. So I think Siddharth had given us like a wonderful introduction and the broad points that we're going to cover. So we can actually move to the next slide, get into the meat of the webinar directly. So primarily what are we looking at in this webinar is the recommendations that CBSE has made through its curriculum for 3 to 8 and the inferences that we kind of made after going through this curricular document. And along with this, what they've also done is they've shared handbooks for teachers and students from class 3 to 8. So all those resources are pooled together in this particular slide deck, and we'll be sharing the entire slide deck post this webinar. So please do attend the entire webinar. There are some interesting things that we are going to uncover here. You can move on to the next slide. Yeah, so let's see what exactly CBSE announced, right? So it is the curricular framework that they announced for computational thinking and artificial intelligence. So we can move, can press the enter button, yes. And this is for grades 3 to 8. So that is the class within which we're looking the framework for, and it is to be implemented this year, right? So that's like the panicky thing for all the teachers, right? So turns out to be, I mean, there are a lot of commonalities, and they've also maybe thought through the entire process. There could be some tweaks that they can make, but I think overall it should be, a straightforward thing to understand and implement. So let us look at what was happening before this particular curriculum framework was announced. So schools used to, choose and build their own content and assessment for ICT classes, right? So schools did know the importance of, say, computer science, even though CBSE did not mandate it for classes, say, 3 to 8, they still came up with their own content and assessment, and they wanted to train and teach their students in computer science and ICT. So the focus was But the focus majorly for that particular curriculum was on, say, computer parts, softwares, how to use software tools, and also coding language, like learning a particular language, right? So that was the focus predominantly. And subjects were thought of as, vertical, say math, science, CS, language. So if you can imagine, vertical strands, and there was not really, a connect between these subjects. But real world does not work like that, right? And here is where, CBSE kind of uses CT as, the connecting thread between subjects that are being taught across. And it also gives like a mindset to the child that, okay, so these subjects are of course named as different subjects, but there is always some commonality, and that can be achieved through, say, computational thinking. Can move on to the, yeah. So this is like a small visual which kind of shows how, CT kind of is the integrating part for across subjects. And that's how CBSE also is looking forward to implement CT. So what is expected post this curriculum announcement, right? So we're going to have CT and AI as a mandatory subject. And there are different ways in which it is going to get implemented for classes 3 to 5 and 6 to 8 that we're going to see in the later slides. So there's also going to be standardized way of assessing CT and AI skills. And finally, so there's also going to be clarity and on roles and responsibilities of who's going to take CT and who's going to take AI, right? So these are some of the things that we're going to look at. Now let us look at how the curriculum is going to work for the primary and the middle school. So the grade 3 to 5 is called the preparatory stage, and it is recommended by CBSE that we're going to spend around 50 hours for 1 year. And this is going to be handled by teachers from math and the world around us, right? So basically the EVS science subjects. And these are the teachers who are going to handle this. And it's going to be integrated. It's not going to be a separate subject called CT, but it is going to be integrated into this particular subject. Now, what are these computational things? So we can actually look at some of the computational things that are going to be, taught and tested. So it's abstraction. Basically, abstraction is when you extract the necessary information to solve a particular problem. So you can think of abstraction as that. Decomposition, again, is breaking down, a larger or a complex problem into smaller chunks so that you're able to solve, in smaller chunks and piece them together to solve a larger problem. Now, pattern recognition, again, is you recognize, when there is a lot of data. So for example, I will probably give data analysis and pattern recognition. I'll keep them together and give an example. So when you have like a lot of data around for a particular problem that you're trying to solve for, you try to identify certain patterns in that data and try to, have a solution that might work for multiple cases, right? So if you are able to identify those patterns, you are also able to identify solutions that can work in multiple scenarios. Coming to algorithmic thinking is, again, step-by-step thinking, procedural thinking, so that you can actually achieve. And this can be communicated to either a fellow human, or it can also be, told to a computer to just follow these instructions and solve for it. Now, the last one is interesting. They also have mentioned troubleshooting, which is basically debugging in coding language. So learning kind of happens maybe not in the first attempt when you're trying to, explore something, right? It's always through troubleshooting. So when you make mistakes and try to identify what went wrong, so that's when, learning actually happens at a deeper level. Now let us look at the middle stage from grades 6 to 8. So it actually bumps up twice. So it is at 100 hours per year. And it is, again, the 100 hours is chunked into 3 categories. The first category is 40 hours. It's basically the continuation of what happened in the primary grades. So it is again integrated into maths, science, and other subjects. And so this is 40 hours out of the 100 hours, 20 hours. Now here is where the computer science teacher's role is kind of consolidated. So 20 hours is taken across grades, of course, 6, 7, and 8. Will be spending 20 hours each, wherein they'll introduce AI and then they'll go into advanced AI along with interdisciplinary projects. So that is also something that we'll see, and that is going to be handled by the computer science teachers. Now, the last segment of 40 hours, so that is, again, the interdisciplinary project. that is going to be handled by the computer science teachers. But again, students, are going to use information from other subjects or skills from other subjects to solve like a real world problem, which is majorly, or mostly interdisciplinary in nature. Right. So it's going to be computational thinking and AI topics for grade 6 to 8, while it is only going to be computational thinking for grades 3 to 5. So this is another differentiation that we have seen in the curriculum. And another important point that I thought was CBSE was trying to tell everyone is it looks at computational thinking as a fundamental skill or a thinking skill, which is, of course, is important for AI. So that is why they have computational thinking in grades 3 and 5. And then they build on that to show AI. And also they say that it is fundamental or foundational for other subjects as well. So this is like the new look or new direction that they are looking how CT can be integrated with these offerings, these subjects. Right. So another important or something that we just observed was, so on the left side is the index of the math textbook that CBSE has, NCRT, and on the right side is the index of from the handbook that CBSE has just released. You can see that there is a one-to-one mapping. Say, for example, chapter 1 says what's in the name, and the third row in the index on the right side says the same thing. So there is a one-to-one mapping between the content that is already there for mathematics and whatever is there for CT. So there are like multiple examples or MCQs and interesting scenarios that CBSE has compiled and put together. So here the expectation is the teacher actually completes the subject, say for example what's in the name, and then they also take in exercise problems from here, from the CT curriculum that they've shared. And this pattern can also be seen along in grade 4 and 5. So if we can go to the next slide. Yeah, we see a one-to-one mapping. And one of the reasons why we kind of see CBSE do this is mathematical thinking and computational thinking have a lot in common, right? So there's always this structural way of thinking, and you also have, say, certain algorithmic steps that you follow. So because of that, I think that CBSE has gone and it's kind of easy to implement in that particular direction, but they've not explicitly set this out. So I think their attitude again is to have CT across all subjects and not only mathematics. And this is like a first step towards that. There will be ways in which they'll try to integrate, say, science. There are few cases or examples that they've already given in the curricular book, but there would be other concrete ways in which they'll start integrating it as the year passes by. We can move on to the next slide. Yeah, moving on to the senior grades. So this is for grade 9. So until now, until say last year, grade 9 had this elective subject called ICT. And what they're planning is for 27-28, they're going to phase out what is existing as an elective and bring something called as it might be called something else, but there is going to be a mandatory subject called computational thinking and artificial intelligence. So this is for grade 9. And for grade 10, the way it progresses, what we feel is it's going to progress into a board examination in 2029 and 30. So that's when they'll probably introduce the first board exam for computational thinking and artificial intelligence. And finally, there'll also be a new curriculum for grade 10 in the future. So that is also expected to be released by CBSE in the near future. So yeah, and the last point, of course, we covered, wherein the board exam is going to start. So this is the plan. So let us see how it gets executed. And I think it's like a great step towards the right direction. So yeah, we'll move on to the next slide. Yeah, we can actually look at what computational thinking is. So this is quite an old video of how Google kind of created when they created the Google Maps, right? So what was the process that they followed? So some of the Google engineers actually are talking about what computational thinking is. So let us look at the small video.
Computational thinking is a set of problem-solving techniques that we use here at Google. One aspect of computational thinking is decomposition, where we take a large problem and we break it down into smaller pieces. Another aspect is pattern recognition. We use pattern recognition to help us identify similarities and differences. The final part of computational thinking is algorithmic design. That allows us to create a step-by-step strategy for solving a problem. Google Earth is a perfect example of computational thinking because it takes a large problem of trying to visualize the entire planet and makes it so that anybody can explore the world around them.
Google Earth is basically an attempt to recreate the whole world in 3D. And we want to make it as if it's the real world. We don't want to make anything up. We don't want to create anything or invent anything. We want to make it the real world. And initially it seems like this crazy problem if you really think about it. The world is huge. It takes a tremendous amount of data. If we were to try to send this to you, we'd have to pull up in front of your house with tractor trailers full of hard drives of all the images. So it seems kind of impossible, but we make it possible. In school, you're given these problems that are very black and white. You know, you either have the answer or you don't have the answer. You got it right or you got it wrong. In the real world,
Sorry, my bad. I was trying to get the subtitles on.
it takes a tremendous amount of data. If we were to try to send this to you, we'd have to pull up in front of your house with tractor trailers full of hard drives of all the images. So it seems kind of impossible, but we make it possible. In school, you're given these problems that are very black and white. You know, you either have the answer or you don't have the answer. You got it right or you got it wrong. In the real world, there are many right answers.
Google Maps is a collection of imagery and data about places and roads all around the world. And using Street View, we actually have images from cars right along all of the streets. Once we've collected all this imagery, we have to somehow put it together in a way to be able to share it with the world. Not long ago, I started getting annoyed with Pegman. Pegman is the little yellow guy on Google Maps that you can drag to get into Street View. And so you drag Pegman from the corner in Google Maps and you drop him on the street you want to get into and look at. That works great when you know exactly where you want to go, when you want to zoom all the way in on a single address and drop him next to a house or something. But say you just want to go to New York City. When I drag and drop Pegman, he'd fall somewhere, well, somewhere random. In fact, he seems to prefer to land in back alleys. He didn't mind landing in the middle of a field. He'd land on big highways, but he'd almost never land in front of a famous landmark. And if you dropped on Paris, he'd never, ever land on the Eiffel Tower. I thought to myself, we can do better than that. We kind of know what famous places are in the world. We should fix this. I began to think to myself, what makes a panorama, one of these images in Street View, important? And then I thought about it further. I thought, when people go to places that are interesting, when they physically travel there, what do they always do when they're in a famous place? They pull out their camera and start taking pictures. People post a lot of these pictures to the internet. So we could look for places that people take a lot of pictures. We can find things that are in those photographs that people took and see if we can find the same things in the Street View images. And so if we can see the Eiffel Tower in the Street View image, and we can see it in a bunch of images people took, we can automatically know that it's probably important. We've worked really hard to make Pegman smarter. When he's dropping from the sky, we want him to land somewhere interesting.
Thinking computationally is a lot more like art than it is like math class. You go in and you know you want to create something and you have a blank canvas, and you use math and you use these tools to paint on that canvas, and you end up creating something beautiful.
Yeah, like a nice video on like what computational thinking is, and this dates back to 2012, by the way. It's like a very old video of Google engineers trying to explain what computational thinking is. And finally, here we are. It is getting integrated into our curriculum for students to experience formally, right? So on that note, so we're going to move into some of the interactive parts of this particular webinar. So these are some of the computational thinking skill-based questions that we already have as part of the ASSET program. So this particular question is a grade 3 question, 3-4, connected to logical reasoning. So the way this is going to work is I'll read out the question, and after that we'll have like a poll, and each participant can actually respond to what they think was the most common wrong answer. So I repeat, do not answer what the right answer is going to be. Like, don't pick the right answer to this particular question, but pick the option that you think a child of grade 3 might have picked as the right answer, right? Ashwin, you're sharing your screen.
Just a second. Yes, we are back.
Yeah, cool. Okay, so the question goes like this. Charu has toy cars, dolls, and books on her shelf. One day, she looks at her shelf and says, I have more toy cars than books on my shelf. From the given options, which shelf belongs to Charu? So Siddharth, can we have the poll? Yeah, so another important information is you can actually move the poll window. So if you're not able to see the question, just you can click on the poll panel and then move it aside. So the question is, guess the most common wrong answer a child from grade 3 would have answered. I think we can look at the poll results. Great. Yeah, 54% of you have chosen option D as the option that a child might have selected, and that is absolutely right. Considering that there are actually more number of books in terms of absolute numbers, right? And sometimes children actually pick that instead of actually comparing, the books and the toy car. That's the reason. So we can go to the next slide, which basically explains that and also shows us the performance. So around 57 and 68% have actually picked the right answer, but a major chunk, close to 25% in each of the grades, have actually chosen option D as the right answer. We look at one more question. The drill is the same. So we're going to select what is the most common wrong answer by that particular grade child. So this is a grade 9-10 pattern recognition based question. A mathematician drew the following sequence of triangles for his students. So there are 3 images. The 2 are in sequence, and basically the last one is the last in that particular sequence. He started with a triangle whose side lengths were 2, 3, 4 units. Then he drew a triangle with side lengths 3, 4, 5. That is basically the first 2 images, and so on. When he finished, the last triangle had side lengths 10, 11, and 12 units, as shown above. Some side lengths appear in 3 different triangles. For example, the side length 5 units appears in triangles with side lengths 3, 4, 5. So that is one triangle. 4, 5, 6. That is another triangle. And 5, 6, 7. So these are 3 different triangles, but 5 appears in all these. Now the question is, in total, for this particular sequence, how many such side lengths are there in this particular sequence? We can have the poll. Thanks, Siddharth. So option A is 6, option B is 7, option C is 8, and option D is 9. We can have the results. Yeah, we can go to the next slide as well. The results show that option C and option D D is close to 28%, while option C is close to 32%. Data shows that option D is one of like the large, the option that is a major distractor, considering that 9 actually is the total number of triangles in that sequence, but not with this particular pattern, while 7 is the total number of triangles with this particular pattern that we have asked for. That is one of the reasons why option D is the most common wrong answer for this particular grade set. Right? Can we go to the next slide? Yeah, so this is again another example of one of the interactives that we have in MindSpark. So we actually have seen CBSE recommend puzzles, like interactive puzzles for grades 3 to 5. And this is one of our MindSpark modules where we are looking at optimization of placing a sprinkler inside a garden grid, right? We can actually play the video. You can just pause the video here. Right now, what happened was there are certain rules for each flower to be watered, right? So rose actually has to get water only from one particular sprinkler, but whereas the tulip has to get water from 2 sprinklers. But in this particular solution, we see that this particular is being overwatered, while the tulip on the right side is being underwatered. It's only getting water from one particular sprinkler. So this is like an error that the child has made, but as we look at how they can actually debug. Yeah. So it actually gives you a way in which you can make mistakes and then finally try to come to the right answer. So this is one of our logic-based puzzle module that we have in MindSpark. Yeah, you can go to the next slide. Yeah, over to you, Ashwini. You can probably take this particular slide.
Thanks, Bharat. Am I audible?
Yes.
Yeah. So one of the things that we were realizing when we read this was, what is the entire take of CBSE on teaching coding itself? Like when we say computational thinking, what do we really mean? And does that kind of go on coding, etc.? So we just search for the term coding and block coding in the entire curriculum, in the entire document. The term block coding appears just once, that too when talking about Scratch, and that too while talking about understanding basic computer concepts, hardware, software, etc. And the term coding itself appears just thrice in the entire curriculum. That too while talking about, okay, what will the pedagogy and assessment be like? And what is the initial focus that is in the preamble of sorts in the beginning. So what does this really mean? Does it mean that CBSE is asking us not to teach coding? What's the deal with that? So what is that shift? So one thing that's clear is that they are not saying do not teach it. They just not seeing it as a central component as computational thinking itself is. So they're talking about thinking skills, which includes computational thinking, digital literacy, AI, ethics, limitations, etc. So that entire future looking curriculum and how all these other skills can serve that thinking core, that essence that you can drive. So that is their emphasis from what we've seen. So you can use logic puzzles, you can use estimations, you can use data literacy and analysis, you can use prompt engineering. Now, I'm sure all of you, many of you might also have heard the word intent engineering. Can you tell the AI what your intent is? Classification and sorting, which is a very core computational thinking skill. And information and media literacy, drawing inference from data, simulations and modeling, and of course also coding. So think of coding as maybe one of the ways to achieve these core thinking skills. So what has shifted is not whether we should teach coding or not, but what are you teaching it with the intention of? What is the final objective of teaching coding? So what CBSE is really saying is that, number one, CT is bigger than coding itself. CT here is computational thinking. In the past, it is used as an abbreviation for critical thinking as well, but computational thinking is what they mean here. And does this teach real thinking, or are you just teaching them mechanical steps and tasks? A lot of curricula teach the initial basic mechanical tasks or the coding principles and then see that as an end in itself. And Bharat will actually show you an example of this mechanical versus thinking task using coding. What does that look like? And also, the question to ask is, does AI already do this better, or will it start doing it better in the very near future? So based on that, the idea is to evaluate the coding curriculum. So the bottom line being, if it is syntax related, telling you put a semicolon here, don't put a semicolon here, write it exactly this way, use this Excel formula, etc., or maybe use this function under PPT, then that is a little less defensible because all of that AI takes care of. So can you slightly focus attention on more higher order skills? So if you're using code to teach thinking, just like all the other skills that we just saw, if we are teaching them how to debug, how to troubleshoot, how to build, how to test, how to think like somebody who's creating something out of nothing, then that is deeply aligned with it. So they are not saying, they're not banning the teaching of coding, they're not prescribing that you teach it. They are saying whatever serves this computational thinking core, you do it.
Yeah. So this is the example that Ashwini is just mentioning, right? So I'll just read through the question. So there are two questions based on this particular context. So this is the context here. So in a certain video game, commands are given to a robot mouse to make it move on the screen. The mouse understands these four commands. So there's like a move forward, which basically means it is going to move forward in that particular direction, one tile. And turn right, it's going to turn right in its place. And it's going to turn left in its place. And finally, we also have a repeat block. So how many ever times you're asking it to repeat, it's going to repeat. Simple Scratch-based problem, block code-based problem. Let's look at the first question. So this is the one where we need a mechanical output. So the question is, the question is, for this particular grid, which code sequence will result in the mouse, apologies for the spelling error there, mouse eating all the nuts in the grid. So there are four options, basically blocks, and we're asking them, what are you supposed to follow in a sequence so that you are able to, so that the mouse is able to eat all the nuts that are there. So the right answer for this is option C. So both P and Q kind of works. P because it gives you individual instructions for individual cells, while Q actually gives you using a repeat block, while the rest of the options does not, give it does not kind of satisfy what the question asks for. So this is pretty much a mechanical kind of a way in which you can ask a particular question. But from the same context, we're just expanding it into an application-based question, wherein we are saying, okay, the grid actually is like a larger grid. So you have to imagine this particular grid. So if the repeat block, so this is where the repeat block in this video is not working. And we're asking them how many commands are needed for the mouse to eat all the nuts in the below 50 cross 50 grid. So maybe you can just answer it in the chat. So we can just take 1 minute. What would be the right answer to this?
I think I can launch a poll for this as well. Just a second.
Sure. It's not which is the most common wrong answer, but you'll have to answer which one is the right answer here. You can look at the answers. Right. A lot of 38% have opted option B, which is 200, which is basically 50 plus 50 plus 50 plus 50, right? So that's like the idea there. And 31% have chosen option C, which is the right answer. Like if you're able to solve the lower band, wherein there are like totally 49 commands from 1 until 50. And if it also has to turn to the left, so that would be 50 commands there. And then you add another 50 here, 50 here. But in the last leg on the left side, vertical side, it'll only have to have 2 commands less. It need not have 50 commands, but it'll stop when it has reached the 49th cell, and there is no need for it to move to the 50th and turn left. So if we had to do that, then the right answer is 200. But whereas it can just stop at 49 so that it actually has accomplished the task asked in the question. So there's more of an application based question rather than just asking them to follow a certain command which is more mechanical in nature. Right. Yeah, we can move to the next question. Next slide. Yeah.
Yeah. Thanks, Bharat. So I think that was a very nice, interesting way to look at what does regular versus slightly higher order questioning look like. And many times we also realize that we also probably need to expose ourselves to these kind of content and questions and challenges. Otherwise, sometimes it looks like we are teaching a particular skill, but we might only be teaching it in a introductory or sort of just touching it in a shallow sort of sense. So the argument is not against doing the mechanical thinking, but more along, let that not be the end goal. Let that lead to a more higher order question. And the larger honest admission we can make to you is that there aren't a lot of high quality things there, but I mean, we still try to put some resources and things that you could refer to at the end. So yeah, just stay tuned in for that. So now, whatever we looked at is the idea that it replaces the ICT or computer lab curriculum. So this is a slightly layered question. It really depends on what you as a school are doing, what you as a teacher are skilled for, what you're comfortable handling currently, and where maybe some upskilling is needed, maybe more resources are needed, or maybe more planning is needed. So currently, if you look at every ICT class, in just looking at, say the India and the UAE, then there are 4 layers in which we are operating, or 4 states in which we are operating. So many of them usually, let's say the slightly underprivileged or state government schools, etc., usually in level 1, which is just looking at parts of a computer, hardware, networking, LAN. So a lot of computer theory. What is OS, what is RAM, history of computing. So interesting. Does knowing the history of computing or computers themselves make me a better problem solver? Possibly not, right? So the right level of abstraction and the right kind of information, the right kind of challenges need to be given, which is why, again, the emphasis on computational thinking comes in. The second layer is using tools and treating that as an end game. So we use Microsoft Suite and then teach PowerPoint or Excel or Paint or Canva. So maybe 3D printing or video editing, image editing. So again, we're not saying don't teach these, but the idea is, can we look at these tools as what is the problem solving or challenge part of the tool versus where I'm just giving them tool fluency, like introducing you to a Paint or introducing you to maybe some 3D printing software, or etc. Instead of looking at understand the principles of this tool, but the tool might change maybe 10 or 15 years later. So for a 4th grader today, when he or she goes into the workspace 15 years hence, when they're 25 years old, we don't know whether they'll use this tool. But can we design the curriculum for them in a way that the principles are taught? So instead of Excel, I'm thinking data analysis, data reading, plotting data, sorting data, filtering data. Similarly, instead of, let's say, focusing on just pure email tools, do you understand when you use a CC, BCC, reply all? So what is the logic behind doing this? And then number 3 is the thinking layer. So doing a Blockly or Scratch. So this is where like the coding layer happens. There's a lot of schools that, of course, have started this even in primary schools, primary classes. HTML, CSS, teaching robotics, again, Excel more from a data and designing, plotting perspective. So this is now slowly entering into the what's truly computational thinking, but it is still not explored the full thinking first way of teaching for the future. So this is still kind of the principles, and there's a little bit of mechanical teaching even there. And we've also noticed that with this layer particularly, there's a lot of time that many of these end up taking. So it's not very learning dense. So it might be a good idea to look at, okay, if I'm taking 25 weeks or 20 weeks to do something, can that be done in maybe 10 or 15, so that I'm actually doing the problem solving rather than just tool familiarity, or the building the vocabulary, the building blocks itself, taking time doing that. And then finally, there is a thinking first way of looking at things, where you're doing logic decomposition patterns, we're collecting data, cleaning data, interpreting it. So very project first, sort of hands-on way of doing things, and best done in groups too, in fact. And then looking at things like biases, critically evaluating information, talking to children about what kind of WhatsApp messages or social media posts that you come across, where a claim or an opinion is presented as a fact. Can you reason through why this is a claim and not a fact? How can we verify, etc.? And then finally, AI literacy and ethics. So based on where you are, based on the resources available to you, based on where your children are, and based on where the teachers themselves are, work your way to the right. And that's like the broad direction that we can recommend. Now, if you're somebody who's already at level 4, which is this, you're already doing thinking first, then that's a great place to bring in some AI forward discussion. For example, can you look at doing AI assisted coding? Can you build simulations with AI? And this is the second thing, is something that we have been so enamored with of late. We've been doing these really fun ways of teaching a child why a shape that has an area, if you remove some part of it, the area reduces, but the perimeter increases because the number of edges, the boundary kind of increase. It's a very visual way of looking at it if you can get AI to create a simulation. Similarly, we learn in science that if you throw a particular ball at, say, 45 degrees, then it lands the farthest. But is there a way that you can show me this instead of taking the textbook's word for it or the teacher's word for it? And then number 3 is AI as a productivity tool as a student, not as a future employee, somebody who's going to have a future job, but now as a student. Can I create a poster? Can I create a small game using it? Can I create a schedule for myself that is tuned to how I study and my household chores and my free time and my tennis time, whatever it is? So can I create something that is useful to me as a student now? And finally, where tech kind of meets language and reasoning, where if you can look at information online, or for example, we discussed looking at an ad and questioning through why is this data presented this way, again looking at fact versus opinion, some critical questions around it, etc. So that layer, if you have the luxury to do, is the sort of final step and the future looking step in all of this.
Yeah. Thanks, Ashwini. So we actually looked at the 3-5, which involved computational thinking, while grade 6, 7, 8, including computational thinking, they also have AI. So we're just looking at the list of topics that are present for grades 6, 7, and 8. So for grade 6, it's mostly introduction of what AI is and how is it different from, say, an automation. And there are, again, like theory-based content, I would say. That's what we are able to see in the curriculum that they've shared, or the handbook that they've shared, and like what are the what are the types of data that AI uses. And there's also ethics. So this is like a very important piece that we thought, and it actually runs across grades, wherein if we see ethics and biases of AI, so that is something that is there across, and CBSE has given due importance to ethics and biases, which is like a very important aspect across. Moving on to grade 7, the depth slightly increases. From introduction, it starts moving into, say, concepts of regression, classification, and clustering, and also advanced concepts such as computer vision and natural language processing. Say, for example, how, say, a GPT or a Claude works. Then also there are applications that they link AI to, like what are the industries that are greatly, in advantage, or how have they greatly exponentially grown, for that matter, because of AI's involvement in these industries. And they also have data visualization and biases in AI. And finally, in grade 8, there is this collaboration that happens across subjects, wherein they are able to build interdisciplinary skills and solutions using AI. So again, there are these set processes that is there in a life cycle of how a AI project runs. So that is something that they learn here. And also there is no code AI tools, right? So for example, in the previous slide, Ashwini explained or gives a few examples of how simulations of various things can be done without knowing coding, right? So you just instruct and try to identify, oh, is this hypothesis that I had, is that something true or not? So through a simulation, without knowing code, a child actually can, try to see if it is true or not. And also fairness and responsibility. Again, that particular strand continues in all of these grades, which is great to see. And finally, building and testing simple AI projects. Again, this would be the interdisciplinary projects, which would again be handled by computer science teachers. So all of this is going to be handled by the computer science teachers, maybe along with the ICT curriculum that you already have. So that is something that we are not sure what CBSE has taken a call on, but this is something that is going to be taken up by the ICT teachers, the computer science teachers. Yeah, moving on to the next slide, there's again another question that we have linked to AI technologies. Again, the drill is the same, wherein we want you to answer the most common wrong answer that a child of grade 5 would have picked. So the context is a library has 2 robots. Robot 1 can see videos of visitors and tell if there are any faces in it. Robot 2 can tell who the person in the video is. And you have an example image. The question is, which of these questions can robot 1 answer? Can we have the poll, please, Siddha? Thank you. So option A is how many people are there in the library today? Option B is who is the boy standing next to the librarian? Option C is how many times did Drina, like basically a character, come this week? Who are the people standing in the line? You can look at the results, and we can also move to the next slide. Yeah. So a lot of people actually have gotten the right answer. I think a lot of you would have answered for what the right answer is. So the data actually shows that it is a marginal thing for option C, wherein it asks about how many times a particular character comes in a week, right? So probably the reason could be the way it is structured, because the word who clearly says that, okay, it has to be a particular person, and the example kind of helps them eliminate it. But whereas option C kind of has that information later in that particular option. And hence, it's a very closely contested wrong answer options. Yeah, can move on to the next one. There's one more question on cyberbullying. So the drill is the same. So please answer what the child might have picked as a wrong answer, which is the most common wrong answer and not the right answer to this question. Let's look at the context. It says cyberbullying is when someone uses chats or online posts to shame or hurt another person. In a class group chat, Sam kept sharing screenshots of Riley's grammar mistakes with a laughing emoticon. Soon, Relay stopped posting on that group. A few of their classmates discussed this situation. I hope the conversation or the speech bubble above each student is visible, so you can actually read through it. Right. So the question is, which classmates are correct as per good online behavior in the class group chat? We can have the poll.
Before we launch the poll, is it possible to zoom in a little bit? I think just for that particular, just for the speech bubbles, it might be useful.
Sure.
I don't think it's letting me do that. So maybe on your screen, if the participants can zoom in.
Yeah. Okay, I launched the poll.
Yeah.
Maybe you can read out what each student is saying. It
Sure.
would help.
So student 1 says, I think this is cyberbullying. Posting someone's mistake to mock them is harmful. So that is student number 1. Student number 2 says, but it was meant as a joke. Sam did not mean to do any harm. That is student 2. Student 3 says, Relay stopped posting on the group. Sam's actions clearly caused harm. And student 4 says, teachers also correct our grammatical mistakes. Sam was just teaching Relay good grammar. So based on this, we'll have to identify what the child would have chosen as the right answer. We can have the results of the poll. And we can also move on to the next slide. Right. So overwhelmingly, a lot of students actually got from grade 7 to 8, more than 70, close to 75% of them actually got it right. While option A, again, just by a little, thinking that student 3 is actually not, confining to good online behavior. So that's actually a minor, percentage of students who are actually chosen. So this is a good sign, I would say, thinking that students actually know what good behavior, online behavior is. Now, let us look at another example. This is called
inspired me to find future.
Yeah, this is called Bias Busters. This is again an interactive that we have under our MindSpark modules. So let us play the video.
Builders for their new ad. I created for image options based on thousands of photos of construction sites.
So if you can just pause the video, I'll just explain what's happening. So here a robot actually was trained in n number of data. So it has seen so many people associating construction, and the objective for this AI, or someone actually asked the AI to give them images of construction workers, right? Like what would they, or who would resemble this particular post or character. So it actually has given 4 different images, and on the right side we are asking the child to select those profiles which who would actually feel left out. So we are trying to identify, okay, what the AI might have been trained on. So on the left side there's a chat, and on the right side the child has to pick the options. Yeah.
Why do you think these specific people would feel left out?
So this is an AI that is asking you, and the child actually is responding to the AI, and the AI would reply back based on whatever the child has actually answered. Right. So all the women in this particular cohort actually would feel left out. So that is like the learning from this particular example. Right. Can move on to the next slide. Yeah. So this is the last piece in the entire puzzle, wherein like how is assessment going to happen, right? So in the preparatory stages, what we are seeing is written test, interactive group activities, and teacher observational journals. And again, this is to be handled by the mathematics and the science teachers. While in middle school, again, the process is very similar. in addition to whatever is there in the preparatory stage, we also have, say, thematic projects or interactive group activities, and also reflections and group discussions, and also the interdisciplinary projects, which will form like the major chunk of how assessment is going to happen. And that is something that is going to be handled by the ICT teachers. But whereas the CT part is again going to be continued and assessed by subject teachers who are going to handle it. Right? So that's like the suggested assessment method by CBSE. Can go on to the next slide. Yeah.
Yeah, so Bharat mentioned that for grades 3 to 5, there are 50 hours of content or 50 hours recommended. And for 6 to 8, it is 100 hours. So how do we look at this breakdown? How do teachers handle it? So, and the grades 3 to 5 part is fairly straightforward. So they're recommending that the math and the world around us teachers handle this together. The math part we already saw. So Bharat will later just show you the handbooks, the teacher and the student handbooks, if you've not seen. They just released a week back. So for every grade, so grade 3, grade 4, all of them have handbooks, and then there is a match with the math topics. So our expectation is that they will integrate this within the maths textbooks in the coming year. But for the world around us teachers, we've not seen anything specific on the handbook, but we can broadly infer that this is what they want to do across the 4 major CT skills. So for math, looking at rotation, symmetry, flips, rotations, folds, 3D, there's a lot of emphasis on spatial reasoning from what we saw. Pattern recognition, mixed kind of patterns, number patterns, geometric patterns, visual patterns, decomposition, breaking word problems, reading data, and also listing instructions step by step. For the world around us, the idea is whether something represents identical or different objects. What is relevant, what's not relevant when you actually read a particular question. Or patterns in nature, classifying items, sorting items, breaking an event into different causes, looking at their effects, looking at a system and breaking that into small parts. So all of that might fall into the world around us. So this is version 1. This is assuming that there is no involvement or there is no integration currently that you are looking for with the computer lab or the ICT class. But again, coming to if you have that luxury, if your computer teacher is trained, if you have the resources available, one idea is to buttress this or support this along with doing logical puzzles and spatial reasoning digitally in the computer class as well. For example, where do you see AI in regular life? Looking at recommendation engines, discussing those, like we mentioned, fact versus opinion. It's a good idea if you can start having these discussions slightly earlier with the children. And the ICT lab may be well placed because our sense is otherwise the math classes are going to be quite burdened to also do the 50 hours of CT skills. So that is for grades 3 to 5. Now for grades 6 to 8, where they're recommending 100 hours, this is actually a lot more straightforward if you can figure out the integration or the coordination aspect of it, which we think might be the biggest challenge. So for the CT aspect of it, so math, science, and English can basically look at advanced CT concepts. Like for math, again, it's fairly straightforward. The handbook also has a lot of examples. For science, again, looking at the scientific method, observation patterns, hypotheses. Those of you who've seen the science asset questions, they are very close to what the CBSE is recommending that CT integrated with science look like. And similarly for English, evaluating claim sources, the information and media literacy part can sort of be handled under that. A lot of clear instructions either to a human or to a machine, which is what working with AI is like, can also be handled under English. So that's a very good place to do it. In fact, we've seen a lot of like Jensen Huang, who's the NVIDIA CEO, also talk about how the next big coding language is English, which is already here. So it's a great place to talk about those skills and build them. And also the AI literacy part of it then moves to the computer lab, the ICT class. How does it learn? What is bias fairness? For example, the example that Bharat showed, prompt instruction design, vibe coding, which is a very, very popular thing to do these days, and also a very higher order, purely human thing to do. and also looking at the AI project lifecycle. What does that look like? And the projects are something that the computer teacher can lead with, as you can see, contribution from math, science, English, and other teachers if they can contribute. And one good example of doing this would be, say, if you take a project like how much water does our school use, and is it okay to use that much water? So the math contribution would be data collection, analyzing it. The science contribution would be measurement and looking at the variables, what is changing, what depends on what. The English contribution could be presenting those findings in a way, in a human readable way, and evaluating the claims, prompting design, etc. with AI. And finally, the computer teacher can sort of put all that together, lead it, be the coordinator for this, bring in the right kind of tools, analyses needed, and then just tie the entire project together. So, and assess it in the computer lab, computer class is what the recommendation is. So we've taken, in fact, even before CBSE's curriculum came out, we were looking at something very similar because we also realized that a lot of skills needed for the future are of the thinking type because the technology is going to fade very quickly. What is lasting is the thinking skills. So we will, of course, share this slide with you, but the way we've kind of looked at it and actually put down the activities, the curriculum, almost the syllabus at every level from, say grade 1 to 8, looks broadly like this. A lot of emphasis on logic puzzles, basics of coding, data analysis, AI foundations, being productive with AI in the early grades, critical thinking and digital literacy also kind of be taught earlier on and not wait till they are in, let's say, grade 6, 7, 8. But then, as you can see, the logic puzzles slides starts to fade slightly as the emphasis then shifts to advanced AI concepts, critical thinking, digital literacy, and of course, interdisciplinary projects. So this was a curriculum that we had put together sometime last year. So it's very interesting that, it all kind of says the same thing. So experts around the world kind of converging on what it means to teach thinking skills for the future. So this again is available publicly. And just for now, the very next question would be, okay, we broadly know the roadmap that we need to take, but what kind of references could we look at? What are some good sources from where we can take questions, worksheets, challenges, MCQs, unplugged activities, etc.? So just a few examples for you. Many of you might have heard of the Bebris Global Challenge. They're fantastic in terms of doing good, high-quality MCQs for computational thinking. We've hardly ever found any errors in these, so they're beautifully designed. In fact, Bharat here and every year contributes one question to this challenge. So yeah, we're a big fan of the work that they do. So they run from grades 1 to 12. So they have content across the global. There's also an India website, Bebris India. So they are definitely worth looking at. Lots of great questions. All of them are around the computational thinking skills that we saw. And these are freely available and these are unplugged. So there is no digital dependence. You can print them out. Another is brilliant. Now this one is, of course, paid, but they are excellent in terms of exposing both teachers and students to some really nice activities, exposing them to some of these more future-looking curricula, future-looking activities, like talking about neural nets, explaining to a child how that is done, and using very interesting contexts and examples to do it. So if you don't have the resources probably to run it in the classroom, a good idea might be to even buy a few licenses as teachers among yourself, work on it and see if something can be transferred to the children, even unplugged. So, but I should caution you that these are slightly higher level activities. So they do not start from a very young grade, or, the difficulty builds quite quickly. And this is a digital resource. The third one is CS Unplugged. Again, fantastic in terms of doing unplugged free printable worksheets. So these are mostly to do with computer science concepts. But at this stage, it is as good as math, because a lot of it, although it is eventually to do with computer science, it builds the base for just logic in general. So lots of fun activities, unplugged activities that you can print. It's in the name, right? CS Unplugged. So you can print and do these in class. And Yeah, again, free resources. The last one is so TED Ed, if you heard of them, they do these fantastic riddles. These again are slightly higher order, but it's a good activity to do in class and discuss with children, possibly even have like your more smarter or those who tend to kind of maybe disrupt the rest of the class because they're done with their assignments very quickly. So discuss this with them and have them break their brains on this, etc. So again, digital, free resources. So yeah, these are some. We've also added a bunch of others which you can refer to. So all of these are free. The only paid one here was brilliant because we really like their content. So we wanted you to be aware of them. But everything else here is free again. We will share all of this with you. And across different grades, like Hello Ruby is for younger kids, AI for K-12 is for KG to 12. A lot of them offer both digital and unplugged. So whatever suits your schedule, whatever suits your format, you're welcome to use.
All right. Yeah, thanks, Ashwini. A quick time check. I think we are 6 minutes past 6. So we'll just quickly go through the rest of the slides. So here we've just put all the links to the handbook that CBSE has released in one place. So this slide shows or gives you the link for the teacher's handbook, while the next slide actually gives you the links for all the students' handbooks. So this is like one place where you can access all of this. Couple of announcements as well, like what we do as AI and digital thinking team at EI. So we have a WhatsApp community, which is 300 plus members strong, and we actually have these bi-monthly polls where we ask interesting questions in terms of how it connects to say a CT or an AI or digital literacy, and we also post interesting webinars and things that are happening in the world of AI. And so yeah, so it's like a happening place, and I would request you to join this particular WhatsApp community. So you can either scan this particular QR code, or I think Siddharth has already shared the link on the chat. So please feel free to just click on that and join the group. There's one more announcement wherein we actually are doing a pilot for our asset-based questions. So the questions that you saw earlier are asset questions, and we actually are running a pilot program. So this is entirely free, and this starts from grade 3 to 10, and it takes around 90 minutes for one pilot program to complete, and it is entirely digital in nature, right? And the school actually gets, say, a very brief report on how the students performed or how the class performed, and also a webinar for their teachers in terms of how they can integrate AI into their classrooms. And one of the major objectives why we're kind of doing this is we want to test our own questions and see if it is age appropriate, and also if the cognitive load in these questions are right. So that's like the major objective of this. So if you're interested, or if your school would be interested in this, so there is again like a link that Siddharth is sharing on the chat, and it is also available on this particular slide deck. So we'll share this slide deck with everyone, so you can reach out to us through this particular form, and we'll get back to you on this particular with more details on the pilot itself. Yeah.
Just to add to Bharat's point, this is free of cost. It's a pilot. We want to create good quality AI and digital literacy and computational thinking questions, which means actually taking user feedback, speaking to children, speaking to teachers, speaking to principals, and actually getting expert reviews on these, which we are very, very particular about at EI. So yeah, just sign up if you think you have the time or the interest to talk to us about this, have your kids solve some questions, have us come and speak to them about this, etc.
Yeah.
We also realized that we will need many more sessions because this was just our first information session, and I know we already run over time. But yeah, just be tuned into the EI webinar space, and we'll also keep informing you when we do future sessions on how exactly this curriculum can be actioned, particularly the AI part of it. The CT, there's a decent bit of clarity. On the AI side of things, we felt that some more clarity would really help, as many of you have already let us know. So kindly scan the link, scan the QR here, and give your feedback. Those who've attended the entire session, we will reach out to you and send you the entire PDF for today's session, along with the links.
Hey, thank you, everybody. I guess, yes, as Ashwini had rightly pointed out, all of the links that we've actually mentioned in this webinar has been shared on this particular chat, as well as the YouTube live chat as well. So please do take a look at all of those resources. We are here to kind of help improve the AI and CT education in this country. And we're very excited about this new update. And I know that a lot of you are also going to be very excited about where this actually takes us. And finally, yes, please do share your feedback. Let us know what you think of this webinar, how we can improve. We would always love to learn more. Thank you for joining us, and I hope you guys have a nice day.